All right, people, start queuing up questions, because that's largely what we're going to do today. Nope. All right, so let's start talking about, so what we've been doing the last couple lessons is just going incrementally, introducing you to the sort of features of Java objects. And to be honest, over the first couple lessons, we really kind of did the heavy hitters, right? So, and this is, again, the material here, this is the point in the class where the challenge changes. The challenge goes from, understanding like the intricacies of how a particular piece of code is executing to this more conceptual idea of understanding how we represent stuff and understanding the features of Java's object system. And so, on some level, again, if you look at the code that we're actually writing here, this is like really straightforward code. This is almost might seem babyish, like stuff that we were doing the first week. I've got, a method that does 2 assignments, and then I've got a method here that multiplies 2 numbers, right? But what's new and what's important to kind of continue to look at and practice with this is this idea of being able to create our own types. That's what that's the thing that's really interesting and exciting here. And we're gonna go slowly. We start off slow. We continue to practice. We give you guys lots of opportunities to see different patterns here. Today is the first example of a place where it's kind of like up until today we could do. If you just took the last 2 lessons on using objects to kind of merge together multiple pieces of data, and then also adding instance methods that can operate on that data, that's really all you need. What we'll be talking about over the next couple of days is more of sort of conventions and extra features of objects that allow us to use them more effectively. And so one of these that we present today is this idea of a constructor. So in the past, if you look at kind of how we did things, so I have this simple class that I've created. This is a person class. What I'm telling Java is that every instance of a person has 2 attributes or fields or instance variables. One is called name and it's of type string, and the other is called age and it's of type double. So when I create a new person object on line 5, I can now set these fields using dot notation. But this is kind of awkward, right? In the sense that every time I create a person now, those fields come uninitialized. They come with the initial values. And the initial values for the primitive types are pretty much all 0 for all the numeric primitive types. Boolean is false. And then for any type that's an object like a string, the default value is null. And that's actually particularly problematic because we've seen some of the issues that null can cause in our programs. And so rather than this pattern where, every time I create an object, I have to go through one at a time and set all the fields on the object, Java and other languages that use objects, and this is a very common idiom, by the way. This is, this pattern of providing a special method that gets called when the object's created is one that's used in Python, it's used in C++, it's used in, a bunch of other languages. And this method is called a constructor. And that's kind of what we're looking at today. And so you see an example of a constructor here in the example that leads off the lesson. A constructor is, on some level, you can think of them as a special method. It's a method like the ones that we've looked at in the past, in the sense that what's inside this block here is just code. It's just code that gets executed. What's special about the constructor is when it runs, because the constructor is executed when instances of the class are created. And so if you look down here, when we were creating new instances in the past using the new keyword, we were we had to like have this empty pair of parentheses here, and we pointed out as we were doing that it kind of looks like a method call, and we were kind of foreshadowing what we're talking about today, because it is a method call. It's a call to the constructor, and so that's when the constructor runs. One important thing to understand about constructors is that's the only time the constructor runs. The constructor is not a method that you can call it and at other times. So once I have an instance of this dimensions object, that in here, in this example, I'm calling room, I can no longer call the constructor. Now, the constructor could call like another method that I can then call later, but there's no way to directly call the constructor again. That constructor is only run once when the object is being initialized. And so that's one of the things that's special about the constructor. If you look at the declaration of the constructor, there's something sort of interesting. So in the past, when we looked at our method declarations, we said there were 4 parts. From left to right, there was a return type, a name, a list of parameters, and the body of the method itself. Here we only see 3 parts, and one of those parts is a little weird, right? So I'm missing a return type, right? So there's no return type here, and constructors cannot declare a return type because they always return an instance of the new object on some level, so there's no need to. When you write a constructor, you always know what it's going to return. You also can't return anything in a constructor. You can use the return statement, but what that will do is just cause the constructor to stop and hand back that object in whatever state it happens to be in when I reach the return. But I can't return a value explicitly. So it's almost like void in a way. Like you can use return without an argument, but you also don't declare a return type for the method. The other thing that's a little weird about this method is the name. And what you'll see here is that the name matches the name of the class, and that's required. So if I change this to small dimensions, now it's just a regular method, and what Java is whining about is that I need to have a return type, and I could do this, but now I'm basically writing a regular method, right? I'm not writing a constructor. So the constructor has to have the same name as the class. Because class names are capitalized by convention in Java, this means that constructors are really the only method that I can think of that we ever write that has a capitalized name, because it has to share the name of the class. Again, if I called this like something that didn't share the name of the class, now Java is just treating it like a normal method. There's nothing special about it. It's not a constructor, and I need to provide a return type and stuff like that. But once I give a name that's the same as the class, now I have an actual constructor. So that's really all there is to today's lesson. There's a couple of refinements that we discuss in the interactive walkthroughs below. One is that I can have multiple constructors with different signatures that I can use to set up the object differently. And the other thing to point out is simply that I can use a return statement in a constructor, and that will just cause the constructor to stop and return the object in whatever state it's in. So for example, I could do something like this here. I could say if set width is less than 0, return. And then what's going to happen here is if I call the constructor with -1.0, it's going to return 0. And what I'm going to show you here is that room.width is 0, but room.height is also 0. The reason for this is because width was less than 0. I entered this if statement. I can put code in here. Let's see. I'll just put something that prints returning. Again, this is just another method, and it works the same as other methods. There's nothing magical about it. I can print stuff. I can have if statements and loops and other things. We'll look as we go forward into other things that you can do in constructors in order to solve particular problems. But for now, the pattern that we're going to get in is typically the constructor is just going to set some fields on the object for us. So, again, here's an example of a constructor return, and then there's some examples below of overloaded constructors. So providing multiple constructors with different arguments. For some of you that may be coming from Python, you might be used to this. Python has this syntax for default arguments where I can basically say something like this. Now Java doesn't do this. What this would mean in Python is that if I don't provide a second argument, set height gets set to 0. The way you accomplish something similar in Java, and again, I know it's not as convenient, is you would do something like this, right? And then you would say height is equal to 0. And this is how you could provide two constructors. And now what we can see is that I can initialize the constructor with only one field. When that happens, I run this constructor. One comment, and we'll talk more about this probably tomorrow or on Friday, but just as a little preview, constructors can call other constructors. And so you might wonder, like, can I just find, when I'm running my constructor, can I figure out a way how to call this constructor? And the answer is yes, and there's an interesting syntax for it. And again, I'm getting ahead of myself a little bit. This is not covered in today's lesson. But the way that we do this is we actually use this special keyword called this. So this will do the same thing. So what's happening here, I'm providing two constructors. One takes two double arguments, one takes one double argument. When I create the new object here on line 15, Java says, okay, well, you're creating a new object and you're passing one double argument to a constructor. Let me see if I can find a constructor that takes one double argument, and it finds this one and it starts executing it. And I can put a print statement in here, favorite print statements of all time. And then I'll put a print statement in here as well. This double constructor. And which, let's see here. Oh, right. Yeah, it's angry about this. Yeah. If I getting ahead of myself. So if I call, I'll just leave that statement in there. So what you see is going to happen here is that even though I'm starting in this constructor, I can't put a print statement there because Java has the rule that if one constructor calls another constructor, it has to do that is the first thing. Again, we'll cover this more probably on Friday when we talk about some additional sort of tweaks and refinements of patterns for working with objects. But anyway, so far, what you need to know is that I can provide multiple constructors with different type signatures, and Java will find the one that matches the arguments if it exists. If it doesn't exist, like I just did here, then nothing happens. So, all right. So I'm pretty much out of stuff to talk about for today. Today's lesson is small and incremental. There's a homework problem on it, so please work on that. So at this point, I'll take questions kind of about anything leading up to this point. I know you guys have been somewhat preoccupied with the midterm for the past couple of days, which I get. And so even though I've decided to continue the lessons this week, the lesson content for the past couple of days has sort of been a little bit lighter than usual, right? And I think this is also really good because objects are a concept that takes some time to wrap your mind around. And so just doing a little bit at a time is probably better. But today, the rubber starts to meet the road because it's actually a homework problem and we're actually asking you to do some stuff. So anyway, questions or sort of comments about this, I'll hang out for maybe 10 minutes to see if there's any interest in questions. Are we allowed to ask questions on the midterm? Yeah, why not? I mean, if you I'm not going to show any of the problems from the midterm, but if there are like general questions about the midterm that I can answer, yeah, sure, go for it. Questions on the midterm, questions on this particular idea or the last couple of ideas. I am open for business. No. So the question was about the um, number of multiple choice questions on the quiz. So the midterms typically have fewer multiple choice questions where each is worth more points, and then maybe a little bit more programming content, although I'm not sure that yesterday's midterm was a good example of that. The quizzes, so if you think about it, like the midterms are designed to show that you can integrate the information that we provided over the, a big chunk of the course. The quizzes are really just to make sure that you're like putting in the weekly work. So the quizzes typically have a larger number of multiple choice questions that are simpler and worth fewer points for that reason, right? So next week's quiz, it's like, what's the keyword that you use to open up a Java class declaration, right? I mean, I'm not going to give 4 points for that question. It's just too basic, right? It's like literally kind of, have you been following along with the lessons and the walkthroughs and stuff like that? So the number of multiple choice questions typically tends to be higher on the quizzes, probably highest at the very beginning of each unit. So like it'll be higher next week on next week's quiz because there'll be a lot of like little questions about the basics of Java objects and some of the syntax associated with them. When we get to the midterm, then the next midterm on object-oriented programming, which should be in about a month, then the questions are more like, higher level. The multiple choice questions are really not, the multiple choice questions are not designed to be particularly tricky or hard. I understand that there's some code reading and comprehension involved in doing those. That's why on a bunch of the walkthroughs that we've been including in the lessons, we do go through code very slowly together and kind of talk it through to give you a sense of kind of how to do a close read of a piece of code. So the number of questions I would say is like lower on the midterms. That's probably a normal number for a midterm, but we'll go up again this week and they'll be smaller and simpler. And the programming questions obviously this coming week will be simpler too, because like it's on object-oriented programming, it's just not a lot you know how to do yet, right? So they'll be fairly straightforward. So runtime errors and compilation errors. Yeah, let's go back and we'll look at, where did we do this? It was here, I think. Error messages, yeah. So this lesson has some good content on the side of the different places where you see this type of thing, right? And so on, the best way to think about this is, in order to, so we talked a little bit about what the compiler does, before your code is executed. In order for the compiler to complete its job, it has to be able to understand. So there's two things the compiler does. One is it has to be able to understand what you've written. If you wrote a poem and gave it to the compiler, it doesn't know what to do with that. And so there's specific structural aspects to your code that the compiler is going to pick up on. So for example, like right here, this is a classic mistake where I've got two closing curly braces, and that just throws the compiler totally off, right? It has no idea what to do with this, right? And this type of error, because of how compilers tend to parse, there's this process of taking, and this is not an upper level course on compilation, but there's this process of sort of taking the code that you wrote and in sort of like breaking it down into smaller pieces so the compiler knows kind of what to do with it. And there's certain types of syntax there that are very, very hard for the compiler to recover from. And so this was a great example of one, right? You might think this is a really small mistake, and on some level it's a one-character mistake. But the compiler just has no idea what to do with this. Same thing if you do something like this. At least here, maybe the error message is a little more helpful, but not really, right? Misplaced brackets can really blow things up. So any sort of like dumb syntax stuff, like same thing here, this is another type of compiler error where it's trying to take the code you wrote and interpret it using the rules of the Java programming language, and there's essentially no way for this statement to parse properly in Java, right? Like there's no syntax in Java where I have type string, type other string, right? And so it gets stuck here, right? And that's because I'm missing this open parenthesis. And so there's this category of mistakes that the compiler will handle, right? And actually now we're looking at the second type. So the first category of mistakes is just like your code isn't valid Java syntax. These are sometimes known as syntax errors. And so the compiler can't even understand it, right? And, this is the thing about computers. Now, I was just actually reading something that, there is a lot of research going into allowing computers to computer compilers and things that run computer programs to do a better job at interpreting human language. So it's possible, like 10 years from now, you'll be able to program a computer by saying, let this, we could say, let this cool function always return true, and Java would be able to figure that out, right? But right now, when we program computers, we're still forced to use the syntax of the particular computer language that we're programming in. So that's the first thing the compiler does. The second thing the compiler does, so once it can make sense of the code you wrote, then there are certain things that the compiler will look for that are mistakes, right? And so here's an example of one. This is a second type of compiler error. So this, first we had these syntax errors where the compiler couldn't even understand what we had written. Now we've written valid Java, except that we're not following the rules of the Java programming language, right? So the compiler understands what we're trying to do. It just knows that there's a problem, right? And here the reason it knows there's a problem is because this function has been declared to return an int. And so when the compiler starts working on this function, it expects the return statements inside this function to return an int or something that it knows is an int, right? If I have an int variable or whatever, it can also figure that out. But in this case, the function or the method is declared to return an int, but my return statement is returning a Boolean literal. And so this is a second example of a compiler error where the compiler is saying, okay, well, you gave me something that I can at least parse and make sense of, but I've detected an error, right, in the program that I'm going to refuse to, means that I'm going to refuse to compile it. And, on some, being such a jerk about this, right? But if I have other code that calls this function and expects to return an int back, and you return true, it's not clear exactly what's supposed to happen at that point. Again, if this was Python, I'd be like, whatever, no problem. And then the other code just crashes because it expects an int. The Java compiler, even though it's not a fantastic compiler, it's better than that, right? It knows that, hey, if you've created, there's an inconsistency here that it can identify, right? Either this function should return a Boolean or you've got a bad return statement. And this is the place where the compiler is actually helping you, right? It's identifying mistakes in your code. Same thing, if I create an int foo, and let's say I initialize it to true or 0, and then say later on in my code I set foo is equal to a string, same thing, right? So these are the types of things that the Java compiler can and does identify for you. Like you're not allowed to change the type of a variable. Maybe you need to store some string data in your program, but you can't put it into foo because foo is an int, right? Again, other languages, whatever, Yeah, I guess you decided to change the type of foo on that line. That's cool. Java doesn't let you do that. It's a little bit more rigid in that way. So these are examples of compiler errors, right? So either syntax errors that render what you try to write as Java not something that it can understand as Java. And it can still be mostly Java. Like this is mostly Java. It looks like it's mostly correct. There's just like one tiny mistake. But what tiny mistake in a file will just basically cause the compiler to just give up, right? It's not particularly resilient to this type of stuff. So once you've written valid Java, the other thing the compiler looks for is inconsistencies in your code, and particularly in Java, this has to do with use of types, right? So if you create a particular variable, one type, try to assign a different value, the compiler will notice that. Other things that it can notice, like, so for example, if I do something like this, if value is less than 0, else return true, right? And I'll say, I'm just making this up, whatever is equal to 1. So let's say I wrote this code. This is valid Java. And let's say that we screwed up and we decided this should be a Boolean. Well, now it's complaining about a missing return statement. Why? So the compiler is able to analyze this code and notice that if I enter this if statement, then I'll never hit this return statement that's in the else, and there's no return from this function. So this is another type of thing the compiler can check for. It can check to make sure that every function has a return. So no matter what path my code takes through my cool function, it needs to eventually reach a return statement. And so this is, this is an example again of a place where we have a problem, right? And these type of problems that the compiler catches, you should really look at it as your friend. It's a helper. I mean, I know that it yells at you and says mean things, but it's helping, right? It's helping you solve problems because in this case, again, like the function has to return a Boolean. If somebody calls this function, they're expecting it to produce a Boolean value. If you don't produce a Boolean value, what's supposed to happen, right? Again, other programming languages just don't handle this problem. They're like, oh, well, they'll basically hand back kind of the equivalent of null and hope that the caller is prepared to deal with that. Java is stricter. Maybe it's a good way to say. I mean, I think, once you start working with languages for a while, you sort of like project human personalities onto them, right? And Java is a nitpicker. It is just like, that's how it is. And I'm somebody was complaining on Reddit, this class has made me hate Java. Well, yeah, I'm sorry about that. Sometimes writing Java makes me hate Java too. The Java compiler is very, very nitpicky. It's strict, right? It doesn't let you get away with stuff. Sometimes it's like, that you should be able to do a certain thing, but the compiler doesn't understand that, and so it's still yelling at you. And so you just sort of, this is something that you get used to, and you get used to understanding how to satisfy it. On the other hand, because it's strict, the code that you write is more likely to be correct right away than code that you wrote in other languages. So I still remember, oh man, how many years ago was it? It's 2020. Maybe like 20 years ago, I think of actually exactly 20 years ago. Last spring, I was taking my second computer science course at Harvard, and the first course was in C, and the second course was a mixture of, I think we did some Lisp first, and then Java, and then C++. And I still remember the first time, so they gave us an assignment to do in Java, and I was working on it. And, I remember writing the code and running it, and it worked. And I was like really flabbergasted because I'd been used to working in C, where every time you wrote code, it crashed like 82 times before you got it to work because of stupid mistakes. And the reality is the Java compiler was helping me fix those mistakes before the code ever ran. And so by the time I got it to run, it turned out to actually be correct, which was pretty cool. So anyway, a good compiler helps you catch errors at this phase before they actually get to the runtime. So the question was also about kind of like what, great question. I'll get to the question about deleting variables. So the question about the difference between runtime errors. So once your code is compiled, it's transformed into this different format, and then Java will try to execute it. There are certain types of mistakes that the Java compiler can't catch. So this is one of these great examples where, let's see here. What did I do here? Does this code already break? No. So here's an example. Let's say that I walk off the end of this array, right? I need to call a function. Let's call search. Well, you know what? No, this is fun. It's a search array. We'll pass it this 1, 2, 5 favorite array, and then 3. And I need to actually, let's see here. Oh, do I need to use new? Probably. Okay. And here's an example of a runtime exception. So this code compiled. The Java compiler didn't notice anything wrong, and you might wonder, like, why not, right? Like, I can look at this code and see that it's going to walk off the end of this array. Like, the bounds of this are wrong, and the Java compiler is not all powerful. And actually, if you go on and take other courses, particularly on courses that look at how computers analyze source code, you'll find out that there are certain types of things that you can know by reading the code, and there's other things that you can only know by executing the code. This is sometimes referred to, the first is sometimes referred to static analysis, and the second is sometimes referred to as dynamic analysis. So you might wonder, like, this loop looks like it's going to walk off the end of the array. Why does the compiler allow this? Well, I might have a break statement inside the loop or something like that causes it to not ever get to the end. And so this might be okay in certain situations. Now, to me, this is sort of an obvious mistake and maybe something that it should have flagged, but it will let you get away with stuff like this. So the compiler compiles it, produces the bytecode that's going to be executed. We start executing the bytecode, and now the code is actually running. And what happens is, at some point as it's being executed, there's an error. And so there are certain types of things that will happen when the code is being executed that Java can't recover from. So an example is I have an array of particular size and I use a bad index. So when I get to this line and I is equal to values.length, which it's going to because I've walked off the end of the array, there's no integer at that location. And so there's no way for Java to finish executing this line of code, right? It's supposed to be comparing two integers, but it can't actually convert the left side of this equality conditional to an integer because I is not a valid index. And so what happens is it crashes. When it gets to a point in the program where it can't proceed or it can't make forward progress, it'll crash. And we'll talk more later in the semester about exactly what happens when this happens and why and how you can use this feature in your own programs and stuff like that. But for now, you can think that it gets to this point, it says, oh crap, you've asked me to pull, like I could do -1 too, right? Or some bogus index. I can't convert that to an int. So there's no way to go on, right? I can't continue the program at this point. I just need to crash. And this is what's happening. This is, Java refers to this as throwing an exception. And again, we'll talk about this more later. But it means that you're trying to, you've asked the Java to do something that it can't do. And these types of errors can slip through in your programs. We'll talk a little bit more later about how to prevent them and how to try to make sure that this doesn't happen. But, you guys have used software and you've probably seen it crash before. Like software crashes, right? Stuff on your phone, like, this app has stopped responding, stuff on your, computer. Like even now, like 50 years later, 60 years into the computer revolution, with all of the fantastic tools we have and all the mature software, like stuff still crashes, right? And this is an example of how that can happen. All right, so it's a question about deleting variables in Java. I think that's a cool question. So can you delete a variable in Java? No. Essentially, well, okay, so let's look at some examples of this. I'll just go to the So one thing to keep in mind is that, if, let's see, so let's say if I is less than 0, int j is equal to 10, else int j is equal to 20, and then I will set int I is equal to 5 or something like that, and I'll run this. So the j that is declared in this block and the j that's declared in this block are totally different variables. So we talked before, and it's probably a good point to kind of have a reminder about this. We'll probably slip this into one of the next couple of lessons about scope. So when you declare a variable inside a block like this, as soon as the block is done, so as soon as I execute this if statement, j is gone. There's no j anymore in the program. Right? There's only a j inside the block in which it's declared. So if I tried to, print j down here, can't do it. So one way to quote unquote delete a variable in Java is to just leave the block in which it was declared. At that point, the Java will forget all about that variable. And then again, down here, I could say int j is equal to 10, and now this works fine. Now I actually have 3 different variables named j in my program. And the only reason this is okay is because this one is declared inside this block and this one is declared inside a different block. Now if I put this up here, I think I'm going to get, yeah, see, here we go. So now I get a complaint. Because when I get inside this block, remember the variables that I declared up here in the outer block are still available. And so I can print, I inside here. That works fine because I is still available to me. I'm inside a block that is inside the block in which I was declared. So our rule of thumb, remember, was that variables that are declared to the left or on the same level as the code that I'm running, if I've indented things properly, are still valid. And so here I can print I, and when I try to go to redeclare j, I can't do that. If I put this declaration of j below the if statement, now there's no conflict because Java is going to execute this from top to bottom, and it knows that by the time it gets to line 8, either one of these variables that got declared, either the j that got declared on line 4 or the j that got declared on line 6, are both out of scope, and so this works fine. And I didn't enter this because I less than 0. If I change this to -1, now I see both of them. Yeah. So we will talk when we talk a little bit more about objects, and we'll talk a little bit, so we did this, as part of our first unit. We kind of, at some point, we sort of, we dived into a little bit of how Java works in terms of compilation and execution. We will do another lesson like that in the future, where we'll talk about how Java manages memory. And this is really interesting, actually. This was one of the things that was really revolutionary about Java when it came out, was that it has this feature called automatic memory management, meaning that it manages the memory in the program for you and doesn't require that you delete stuff, right? And that turns out to actually be, so Java will actually automatically delete things for you when it can tell that you no longer need them. And that turns out to be a really powerful feature. All right, so there's some great questions today. What do I do when I don't understand what the question means? Not sure, like on an exam or on a homework problem, or I'm not sure about the context here. Let me ask for clarification on that, and I'm just going to take my quick break. All right, let's see if there's a little bit of clarity. Don't expect what we're expected to do. So look, I mean, I hate to sound like a broken record, but when you're stuck on the homework, my first suggestion is that you go back and review the lesson content. Today's homework is asking you to do something that's very, very similar to what we were doing on Monday and Tuesday, I think. Well, really kind of, probably end of Tuesday. And so if you go through those lessons and particularly look at the walkthrough content, you'll find sort of examples of, me doing problems look very, very similar to that one. And so I think once you see those, that'll help a little bit. We'll get there with the grade book. It's you can, at this point, the information that you need to, estimate your grade in the class is really all available to you, right? You can go through and note how many homework problems you missed, and you can also look at the quiz scores that are available on the quiz section of the website. And so those are the two grade components that are active right now. And so we'll get that information kind of pulled into one place. but I'm not going to make any promises about exactly when that's going to happen. So far, I think the one thing that we might do in the short term is just put up some page that makes it easier to see which homework problems you've done. That's probably not too much work. And so, because that I think, is a little bit messier to kind of go through and like find every homework problem that we asked you to do and figure out like where it is and whether you did it. But so we might pull that into one spot, but the quizzes, those are kind of all there right in front of you. And so again, it's, I don't, we do maintain, normally we've had a pretty nice gradebook for students to use. I just wouldn't, I wouldn't worry about it. If you're doing the daily homework problems, you're going to be fine. And if you're doing, as long as you don't run out of drops for the quizzes and you're doing reasonably well on those. And again, like that's relative, right? The yesterday's exam, you had people that, lost a big chunk of points because they didn't get one of the programming questions correct. And so I haven't looked at the stats yet, but I would suspect the median was probably in the 70s maybe. And that's, for us, that's just kind of a normal assessment, and I understand, one of the things that goes on in this class is that many of you are freshmen, many of you never seen a grade that was like lower than a 90 or something like that. And by the end of the semester, once we pull everything into one place, you're going to feel pretty good about what you accomplished this semester, but just don't get thrown off by one assessment that's worth a very small percentage of your grade. The goal of the goal of those assessments is to encourage you to do the work. The MP, I think we're going to hold this semester longer than we had in the past, and it will be shorter and simpler and kind of released at a point that's a little bit more appropriate. In the past, we've brought out the MP very early, and I think that at the end of the day, it's we have to remember that there's people in the class that have never done this before and are just starting to get used to just seeing objects for the first time a couple days ago. And unfortunately, even taking Android and making it as simple as possible still introduces a certain amount of sort of unavoidable complexity. And so I think it's actually going to work better for people to start the MP a little bit later in the semester and at a point where they're a little bit more prepared. And so until then, we'll continue the homework problems. We're certainly not going to do the same MP that we did last year, where it was much of a bigger project. We're going to do something that's a lot simpler, and we're going to spend more time trying to make sure that you all understand kind of every piece of it, right? So that by the time you're done, even if the thing that you've created this semester isn't incredibly impressive, you can see patterns that you can reuse to do more cool things, right? Because at the end, that's the other thing I think that, having done this a bunch of times, I'm starting to realize there are these sort of core capabilities that we want you to, and the core experiences we want you to have through the machine project that are designed to sort of bootstrap you for building your own things. But I just have to kind of show you the door, right? Like, for example, a good example is communicating with a web server, right? So part of the MP is going to have you doing some very simple requests for data and also sending data back to the server. We don't have to have you do a lot of that, just to understand that it's possible and show you the potential of doing something like that. And then if you wanted to design your own app that did something similar that could be a lot more sophisticated and have a lot more complexity to it, you have the building blocks. And on some level, it's just about doing more of those same simple things. So, our app might make, 2 calls to a web API. A realistic app might make dozens and have lots of other pieces of functionality that access that way, but it all works the same way, right? It's all just examples of kind of the same pattern over and over again. So that's, this is an intentional change this semester to just try to put people in a better place to do the MP. I've got 4 minutes, so I'll just spitball a little bit on kind of how we've got to this point. So when I got here 3 years ago, the course, it really didn't have the homework problems in the same way. It had this very kind of very tiny set of exercises they did on this platform that people were paying money for, and there was no due date, and so everybody did them like the last week of the class. And so the MPs were really the only real programming people did. And so it was kind of important to get them started early in the semester. Starting 2018, we introduced the homework problems. And so when I took over the class full time in spring 2018, I was very, very aggressive about getting the MP out. That semester we actually released it on the first day, right? So we've tried everything with the MP. We tried day 0, and now we're going to try waiting. And at the end of the, I think it's really fun to do something with Android because it's a real platform that you guys are familiar with. It's difficult to build things in Java that are that exciting without using Android. You end up doing kind of stuff that's sort of dumb. So Android's a great framework for showing you how you can leverage your Java abilities to build real world things. But like I said, I mean, Android is industrial strength stuff. So even a simple Android app is going to have stuff in it that is not appropriate to show people on day 1. And it's probably not appropriate to show people in month 1 either. And so I think that the experiment we're trying is, let's do a simpler MP. The grading is going to be, straightforward. We're going to give you guys lots of support as you go through it. But what's getting you to this point are these daily homework problems. And so it's not like you haven't done any programming to this point in the semester. You've done plenty, right? And in fact, I think you probably have written more lines of code over the first month of the semester than students used to write in the whole class. And so we're definitely keeping your feet moving. We don't need the MP to drive that entirely because the homework problems are out there. And so, for the next maybe 2-3 weeks, we'll keep up with the homework problems on objects. We'll probably slip some other ones in there from time to time that are just to keep you fresh on your imperative programming. And then we'll get to the MP, right? And then we'll kind of show you how to build a simple Android app. And we'll also, because we're going to do a much simpler MP, we're also going to, it's going to allow us to really create, to cover more about what's actually happening. So in the past, we got too ambitious, and it was we would try to give you too much to do. Now the goal is going to be, let's do something smaller and really try to cover all of it. All right, so it looks like all right, so I think that's a great question. As far as today's homework, again, go back, review the lessons. If you're still stuck, jump on the help site. We're there for you. Come to one of the sessions. Those are great chances to get help. I will be back tomorrow. See you then.